Hello guys, welcome to Discrete Mathematics at Slacker University. We appreciate you guys attending the class today, slacking one slacker at a time. We're going to cover our first topic for Discrete Mathematics, the logic of compound statements. And really, this is something we see in our everyday lives. We can find lots of applications to this, and we can start by defining what a statement is. A statement is going to be a sentence which is true or false, but not both. And as simple as this sounds, this is a very fundamental and defining principle for the logic of compound statements. Once we understand this, we can build compound statements, and we can build these statements using symbols. Let's look at an example. If Jake is a math major, and Jake is an engineering major, then Jake will take discrete math. We might see this as a basic sentence that we use in our everyday lives. But what this actually is an argument. And an argument is a sequence of statements that's aimed at demonstrating the truth of an assertion. We can break these arguments down into two parts, a premise and a conclusion. The premise is going to be the preceding statements to a conclusion, and the conclusion itself is the assertion at the end of the sequence of these statements. Let's go back to our original example. If Jake is a math major and Jake is an engineering major, then Jake will take discrete math. Let's take a second here to find the premise and the conclusion. Did you guys find it? Did you see anything funny? There's actually something very unique about this argument, and that is there's actually two premises. Premises one, if Jake is a math major, and two, Jake is an engineering major. We can use this to find the conclusion, which is going to be Jake will take discrete math. Now you might say this is a whole lot to write, and we're math majors. We can find a better way to do this. Of course, we can use symbols and notation. We can use symbols to build more complex logical expressions in the future. And for example, we can use P to define Jake as a math major, Q to define Jake as an engineering major, and R to say Jake will take discrete math. Once we have this, we can go further and use notation. We can use not, and also or. Now, in our case, and and but are one and the same. You might say, this doesn't make any sense to me either. You're probably wondering why I'm even teaching this video. Well, let's think about it. Jake is a math major, and Jake is an engineering major. Now let's say Jake is a math major, but Jake is an engineering major. We're still implying both have to be true. So for our cases, and for the logic of compound statements, and or but are one and the same. Now that we have our notation symbols, there's an order for our notations that we must use. First, the negation applies, and then we use and or. Now that we have all these fundamentals, we can use this to write our example from before as if P and Q, then R. Now this is just the equivalent of if Jake is a math major and Jake is an engineering major, then Jake will take discrete math. This is much simpler and much more efficient, and will serve our purposes better in the future. Now, let's assume that this is true, and this has to be true. Let's look at another example. If not P and Q, then R. Now, what this is saying, due to our order of operations, if Jake is not a math major and Jake is an engineering major, then Jake will take discrete math. So he has to not be a math major and has to be an engineering major for him to take discrete math. Now, if our prior statement is true, this can't be, because we said he has to be a math major. When we use and, we have to be very careful about how we prove or disprove the validity of our statements. What we could have done to make this true is our prior statement could have said if P or Q, and this would say he'd have to be one or the other. So if he's not a math major, then he still could be taking discrete mathematics. Now, this is a way we reason in everyday life. It's a logical way of thinking, but this is a very fundamental principle when it comes to discrete mathematics. We can do more examples, and you can feel free to ask any more questions on our YouTube page. if you have any issues with any of your math problems from home. What you can take away from this lecture is going to be statements and compound statements, understanding arguments and their structure, and the notation symbols we use to simplify our statements. Also, take some time to look over the examples again. And like I said, once again, if you have any questions, feel free to post them on our YouTube page.